Hello friends, welcome to Science Padashala. This is Girish Babu. In this session, let us solve numericals on wave optics. In this wave optics, there is important experiment called Young's double slit experiment, that is interference of light. First, let me go through equations involved in this experiment. Next, let us solve problems appeared in board exam as well as some term exams. Okay, clear? See, let me go through some important formulas and equations that is related to Young's double slit experiment. The first thing is, see, before going to this, we should know what do you mean by slit, what do you mean by screen. See, this is source, this is the source, this is slit 1, S1, that is slit 2, S2. Okay, then distance between two slits is small d, very important. Distance between two slits is small d, and distance between slit and screen is called capital D. Okay, then first formula, that is fringe width formula. What is fringe width? That is indicated by beta. Beta is equal to lambda capital D by small d. Okay, students, please tell every time capital D by small d. If you simply say d by d, so you may get confused when you are solving numericals. Okay, yes. So what is beta? Beta is equal to fringe width, lambda is wavelength of light, d capital D, not d, capital D distance between screen and slit. Okay, distance between screen and slit. Then small d is equal to distance between two slits. Okay, clear? Yes. Now we'll move on to the next equation, that is distance between the nth bright fringe, very important, nth bright fringe from central bright fringe. So distance between distance of the nth bright fringe from the central bright fringe, there is a formula. Formula is xn is equal to n lambda capital D by small d. Okay, this is the formula for this, for bright fringe, distance of the nth bright fringe from the central bright fringe. For example, if it is 6th bright fringe, means n is equal to 6, 5th n is equal to 5. Clear? Now the distance of the nth dark fringe, very important, whether it is a dark fringe or bright fringe, that is very important. If it is a dark fringe, then there is one more formula for that, that is xn is equal to n minus 1 by 2 into lambda capital D by small d. Okay, so there is one more formula for this, that is xn is equal to n plus 1 by 2 lambda capital D by small d. Okay, if we take this n minus 1 by 2, then this n start from 1. If you take this xn, that is xn is equal to n plus 1 by 2, n start from 0. For example, this is, if they'll give nth dark fringe, if they'll give, then n is equal to 5. The same for that nth dark fringe, if you take this formula, then n is equal to 4. So ನೀವು ಯಾವ್ದು ತಗೋತೀರಾ ಅದರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. Okay, if you take n minus 1 by 2, it becomes n is equal to 1. Means if it is 10th dark fringe, then n is equal to 10 only for this formula. But for this formula, n is equal to 9. So ನೀವು ಯಾವ ತರ ಪ್ರಾಬ್ಲಮ್ ತಗೋತೀರಾ, ನೀವು ಫಾರ್ಮುಲಾ ತಗೋತೀರಾ, it depends on that. Okay, there are so many variations in these formulas, but I am following this method. Okay, so if it is bright fringe, we have to remember this formula. If it is dark fringe, you have to remember this formula. Clear? So we have to note down all these numericals and we have to revise. Clear? So we'll go to the first numerical. Yes, see here, in Young's double slit experiment, means YDSE, means Young's double slit experiment, the distance between the slits is 0.5 mm. When the screen is kept at distance of 100 centimeter from the slits, the distance of ninth bright fringe from the center of the fringe pattern is 8.835 mm. Find the wavelength of light. So we have to read twice the question because we have to understand the question first. Then what we have to write? We have to write the given data, what they given. What they given? See, the distance between the slits is 0.5, means distance between two slits. This is one slit, this is another slit, S1, S2. Distance between these two they given how much? That is small d. Small d is equal to 0.5 mm. So mm means 0.5 into 10 raised to minus 3 meter. Then what they given? When the screen is kept at a distance of 100 centimeter. This is the screen, means the distance between screen and slit is 100 centimeter. This is equal to capital D. Okay, then capital D is equal to how much? 100 centimeter is equal to 100 into 10 raised to minus 2 meter is equal to 1 meter. Okay, next what they given? The distance of ninth bright fringe from the center of the fringe pattern is 8.835 they given millimeter. So xn they given, xn they given how much? 8.835 mm is equal to 8.835 into 10 raised to minus 3 meter. What we have to calculate? We have to calculate lambda. Lambda is equal to question mark. So what they given? Bright fringe they given. Already we learned that formula. What is the formula of bright fringe formula? That is xn is equal to which one? Xn is equal to n lambda capital D by small d. So what we have to calculate here? We have to calculate lambda. Then lambda is equal to, so take this small d into numerator, that side xn small d divided by n into capital D. Now substitute the values here. What is xn? 8.835 into what is small d they given? 0.5 into 10 raised to minus 3 into, there is one more minus 3 here, that is 8.835 into 10 raised to minus 3, 10 raised to minus 3 divided by what is n? One more thing, what is n here? N is equal to 9 because they given in the question ninth bright fringe. Okay, so n is equal to 9. So divided by 9 into what is capital D? Capital D is equal to 1. Okay, clear? Yes. So if you multiply this and this, you will get something of 4.417 into minus 3, 10 raised to minus 6 divided by 9. If you solve this 4.417 by 9, you will get 0.4908 into 10 raised to minus 6 meter. So or else shift 1, 2, 3 points to the right side, you will get minus 9, that is 490 into 10 raised to minus 9 meter, that is equal to 490 nanometer. Okay, so lambda. So before we know that 1 centimeter is equal to 10 raised to minus 2 meter, 1 millimeter is equal to 10 raised to minus 3 meter, 1 micrometer is equal to 10 raised to minus 6 meter, 1 nanometer is equal to 10 raised to minus 9 meter, 1 angstrom is equal to 10 raised to minus 10 meter, so etc. 1 picometer is equal to 10 raised to minus 12 meter, etc. So what is the answer here? That is 490 nanometer is the answer. Clear? Find the wavelength of light used, that is 490 nanometer. Clear? Yes. You have to note all these points. So please do your calculations. So I might be wrong. So that's why you have to take calculator and you have to do the calculation part. Okay? Yes. See, next problem is like this. In Young's double slit experiment, light of wavelength 400 nanometer is used. Distance between screen and the slit is 1.2 meter, and distance between the slits is 0.6 millimeter. So what we have to calculate the distance of fourth bright fringe from the central fringe. Second one, the distance of sixth dark fringe from the central fringe, and the fringe width we have to calculate. Okay, so first write down the given data. What they given. See here, wavelength they given, light of wavelength 400 nanometer, lambda is equal to 400 nanometer. Next, so this 400 becomes 400 into 10 raised to minus 9 meter. Okay now. Next, what they given, distance between screen and the slits. See, distance between screen and slit is capital D. Capital D is equal to how much? 1.2 meter. Next, distance between two slits. Distance between two slits means small d is equal to how much? 0.6 mm. So 0.6 into 10 raised to minus 3 meter. Okay now. So let's solve this. So first one, what they given? First A, distance of fourth bright fringe from the central fringe. X4 we have to calculate. X4 is equal to, so which type of fringe it is? Bright fringe. What is the formula for bright fringe? That is n lambda d by, sorry, this is capital D by small d. Capital D by small d. What is n? How much? That is 4. N is equal to 4. Fourth bright fringe, no. N is equal to 4. Then what is lambda? 400 into 10 raised to minus 9 into what is capital D? What they given? 1.2 divided by small d, how much? 0.6 into 10 raised to minus 3. If we do the calculations, see, 0.6 ones are 6 twos are. Okay, then 4 into 400 into, take this 2 into 10 raised to minus 9, take this minus 3 into numerator, 10 raised to plus 3. So that is 4 4s are 16, 16 to the 32, 32 0 0 into 10 raised to minus 9 plus 3 is minus 6 meter. Now, so 1 2 3, so in terms of millimeter, 3.2 into 10 raised to minus 3 meter, that is x4. Distance of fourth bright fringe from the central fringe, how much distance? 3.2 into 10 raised to minus 3 meter. Okay, this is for first one, A. Next, B. What they'll ask? Dark fringe. See, first one is bright fringe, second one is dark fringe. So what is the formula for this dark fringe? That is x6, right, sixth fringe is equal to n minus 1 by 2 lambda capital D by small d. Okay, so what is n? How much? 6 minus 1 by 2. What is lambda? What they given? 400 into 10 raised to minus 9 into capital D, how much? 1.2 divided by small d, how much? 0.6 into 10 raised to minus 3. Say again, 0.6 ones are 0.6 twos are. So 6 minus 1 by 2 means 5.5, right? Let's write down here 5.5 into 400 into 2 into 10 raised to minus 9. Take this minus 3 into numerator, 10 raised to plus 3. So if you do the calculation, you will get 4400 into 10 raised to minus 6 meter. So that is equal to 4.4 into 10 raised to minus 3 meter. That is equal to 4.4 millimeter mm. Okay, got it? Yes, this is for B. This is the answer for second one. Next, see what they'll ask. Fringe width they'll ask. What is the formula for fringe width? That is beta is equal to lambda capital D by small d. What is lambda here? 400 into capital D. Capital D how much? 400 into 10 raised to minus 9 into capital D 1.2 divided by small d how much? 0.6 into 10 raised to minus 3. Again the same thing, 1s are 2s are. So 400 into 10 raised to minus 9 into 2 into 10 raised to plus 3. If you do this, you will get 800 into 10 raised to minus 6 meter. Okay, so or 800 micrometer. Clear? So this is the answer for C. So answer for A 3.2 millimeter, answer for B 4.4 millimeter, answer for C 800 micrometer. So 800 micrometer, or you can convert it into 8 into 10 raised to minus 4 meter. Clear? Yes. See next one. In Young's double slit experiment, wavelength used is 5000 angstrom and the distance between the slits is 2 meter. Distance between screen from the slit is 1 meter. Find the fringe width. We have to calculate fringe width and also calculate the distance of 7th dark fringe from the central bright fringe. See, write down the given data, what they given. So in Young's double slit experiment, wavelength used is 5000. Lambda is equal to 5000 angstrom is equal to 5000 into 10 raised to minus 10 meter. Distance between the slits, that is small d, distance between the slits is equal to 2 into 10 raised to minus 3 meter, and capital D, distance between slits and screen is 1 meter. What we have to calculate? Fringe width we have to calculate, and distance of 7th bright fringe, that is 7th one, x7 we have to calculate, question mark. Okay, so first solve the beta. So what is formula for beta here? Beta is equal to fringe width, that is fringe width or beta is equal to lambda capital D by small d. So what is capital lambda here? 5000 into 10 raised to minus 10 into, so what is capital D? 1 meter divided by small d is 2 into 10 raised to minus 3. Okay, so if you solve this, you will get beta is equal to 2.5 into 10 raised to minus 4 meter. Okay, this is the value of beta. Then what we have to calculate? Distance of nth dark fringe. Which type of fringe it is? Dark fringe from the central bright fringe. That is xn is equal to n minus 1 by 2 into lambda capital D by small d. So what is n here? N is equal to 7. So that is x7 is equal to 7 minus 1 by 2. What is lambda? 5000. So what is lambda here? See, we know that formula, lambda d by small d is equal to beta. Directly substitute this beta value here. No need to substitute again. Beta how much? 2.5 into 10 raised to minus 4. See here, lambda d by capital D by small d. See here, lambda capital D by small d is equal to beta. Beta, we got the answer here. How much? 2.5 into minus 4. They directly substitute here. No need to calculate again. So this is 6.5 into 2.5 into 10 raised to minus 4. Right? Yes. Now, if you multiply this, you will get 16.25 into 10 raised to minus 4. So x7 is equal to, so 1.625 into 10 raised to minus 3 meter. That is x7 is equal to 1.625 millimeter. Okay, na? This is the answer. Very simple. So what we have to do, you have to do the calculations. So you have to simplify by yourself, because I might be wrong. Okay, that's why you have to take calculator, do the calculation, you will get the same answer, then fine. Okay, yes. Next question. See, next question, fourth question. Two narrow slits, Young's double slit experiment, are 0.18 millimeter apart when they are illuminated by monochromatic light. Fringes of width 2.7 mm are obtained on a screen 0.8 meter away. Find the wavelength of light used. If the source is replaced by another source of wavelength 450 nanometer, find the change in fringe width. Okay, so first write down what they given data you have to write. Slits experiments are 0.15 millimeter apart. There are two slits. The distance between two slits are 0.18 millimeter. That is small d is equal to 0.18 mm is equal to 0.18 into 10 raised to minus 3 m. Then they are illuminated by monochromatic light. Fringes width 2.7. That is fringe width they given. Beta is equal to 2.7 mm. That is 2.7 into 10 raised to minus 3 meter. Okay. So next, distance between the screen and slit they given. See, they obtained on screen 0.8 meter away. That is capital D is equal to 0.8 meter. Okay, then lambda is equal to question mark. We have to calculate lambda. Then what we have to calculate? Lambda we have to calculate. Then if source is replaced by another source of wavelength 450, so take it as beta 1. This is lambda 1. Then if the source is replaced by another source of wavelength 450 nanometer, lambda 2 they given how much? 450 nanometer. Then find the fringe width. Beta 2 we have to calculate. Question mark. Okay, so first we'll do the lambda. You have to calculate the lambda 1 for this values. That is fringe width formula. We know that beta 1 is equal to lambda capital D by small d. So I want lambda 1 here. So this becomes beta 1 d by capital D. So what is beta 1 they given? 2.7 into 10 raised to minus 3 into small d how much? 0.18 into 10 raised to minus 3 divided by capital D how much? 0.8. If we solve this, you will get 0.486 into 10 raised to minus 6 divided by 0.8. Then you will get 0.607 into 10 raised to minus 3. 10 raised to minus 6. Yes, then lambda 1 is equal to, so shift 3 points this side, it becomes 607 into 10 raised to minus 9 meter. Okay, Arthaitalva? Now we got the value of lambda. Next, what we have to find out, if the source is replaced by another source of wavelength 450 nanometer, new fringe width we have to calculate. Okay, so then new fringe width, I'll write here, new fringe width, that is beta 2 is equal to lambda 2 d by small d. So what is lambda 2? They given how much? 450. 450 into 10 raised to minus 9 into capital is 0.8 divided by small d how much? 0.18 into 10 raised to minus 3. So then beta 2 is equal to, so how much you will get? If you do this, you will get around 2000 into 10 raised to minus 6 meter. It becomes beta 2 is equal to, shift these points, then 2 into 10 raised to minus 3 meter or 2 millimeter, right? So this is the value of beta 2. Then what we have to calculate? Change in fringe width. Change in fringe width we have to calculate, that is change in fringe width with delta beta is equal to beta 1 minus beta 2. Beta 1 how much they given? 2.7. Then beta 2, 2. So 2.7 minus 2 is equal to 0.7 millimeter. Okay, this is the answer for this question. Next, fifth question. See, this question they'll ask in December test and 2017. These all questions they'll ask in 2023, 22, 17, 18, 19. Okay, so next question is like this. In the Young's double slit experiment, the slits are separated by 0.28 mm and the screen is placed at a distance of 1.4 meter away from the slits. The distance between the central bright fringe and the fifth dark fringe is measured to be 1.35 centimeter. Calculate the wavelength of the light used and also find the fringe width of the screen is moved 0.4 meter towards the slit from the same experimental setup. Okay, so first write down given data, what they given. Young's double slit experiment, slits are separated by, slits difference they given. So distance between two slits, that is small d, is equal to 0.28 mm is equal to 0.28 into 10 raised to minus 3 m. And the screen is placed at 1.4 meter. Screen distance between screen and slit is 1.4 meter away from the slits. The distance between the central bright fringe and the fifth fringe is measured to be 1.5 centimeter. What they given? x5 they given. How much? 1.35 centimeter. 1.35 into 10 raised to minus 2 meter. Okay. See here, we don't know lambda here, but beta they given. See what we have to calculate? We have to calculate lambda. Lambda we have to calculate, and also we have to calculate here beta, fringe width we have to calculate. Okay. So now see, we know that formula xn is equal to, what is, n minus 1 by 2 into lambda capital D by small d. So we know that formula capital D by small d, lambda capital D by small d is equal to beta, that is xn is equal to n minus 1 by 2 into beta. So if you do LCM for this, you will get xn is equal to 2n minus 1 divided by 2 into beta. Then beta is equal to what? Beta is equal to take this 2 into this side, xn into 2 divided by 2n minus 1. See, xn we know how much? 5. Oh, sorry, 1.35. That you have to substitute here. What is xn? 1.35 into 10 raised to minus 2 into 2 divided by, what is 2 into n, how much? 5, because fifth dark fringe minus 1. Okay, so if you do this, 2.7 into 10 raised to minus 2 by 9. So 5 into 2 is equal to 10, 10 minus 1, 5. So if you do this, you will get 0.3 into 10 raised to minus 2 is equal to 3 mm. This is equal to, what is? Beta 1. Okay, now we know that formula. We know that beta is equal to lambda capital D by small d. So from this formula I have to calculate lambda is equal to beta small d by capital D. So how much beta I got here? 3. 3 into 10 raised to minus 3 is equal to small d how much? 0.28 into 10 raised to minus 3 divided by capital D how much? 1.4. If you do this, you will get the answer, that is lambda is equal to 0.6 into 10 raised to minus 6 meter, or 600 nanometer, that is 10 raised to minus 9. If you shift 3 points this side, right side, it becomes minus 9, that is 600 nanometer. Okay, now what they'll give, see, this much over, this much is over. Also find the fringe width if the screen is moved 0.4 meter towards the slit. See, d2 is equal to d1 minus 0.4. This we have to take it as d1. We are moving 0.4 meter towards the slit. Okay, see here, what is d1? 1.4 minus 0.4 is equal to 1 meter. d2 is equal to 1 meter. Then what we have to calculate? We have to calculate the beta 2 here. Then beta 2 is equal to lambda d2 by d. D is same for both the cases. So lambda how much you got? 600 into 10 raised to minus 9 is into d2 how much? 1 meter divided by small d 0.28 into 10 raised to minus 3 is equal to, you will get 2.14 into 10 raised to minus 3 meter. You will get 2.14 into 10 raised to minus 3. Yes, this is the final answer for this. Okay, yes, copy this. Please do calculation yourself. I might be wrong. You will get whatever you will get the answer. You just write on that answer. Okay, yes. See, next question will be like this. In a Young's double slit experiment, the slits are separated by 0.28 mm and the screen is placed 1.4 meter away. The distance between the central bright fringe and the fourth bright fringe is measured to be 1.2 centimeter. Determine the wavelength of light used. Also find the distance of fifth dark fringe from the central bright fringe. Similar kind of numerical we just solved. I think fourth one illandre or third one irutte. So same kind of, please do pause the video, ನೀವೇ ಮಾಡಿ ಮತ್ತೆ then come back and check the answer whether what you solve the answer whether it is correct or wrong. Okay, so first write on the given data what they given. The slits are separated by 0.28 mm, that is small d is equal to 0.28 mm ಕೊಟ್ಟಿದ್ದಾರೆ, that is 0.28 into 10 raised to minus 3 meter. Okay na. next ಏನು ಕೊಟ್ಟಿದ್ದಾರೆ, and the screen is placed 1.4 meter away. Capital D they given. So how much? 1.4 meter. So the distance between the central bright fringe and fourth bright fringe, n they given. N how much? 4. And xn they given. Xn 1.2 into 10 raised to minus 2 meter direct agi ಬರ್ಕೊಂಡಿದೆ. Okay, what we have to calculate? Lambda is equal to question mark. So we know that formula, if it is a bright fringe, we know that formula xn is equal to n lambda capital D by small d. Okay na? Then what is lambda here? Lambda is equal to xn d divided by n into capital D. Yes, substitute the values here. Xn how much? 1.2 into 10 raised to minus 2 into what is small d? Small d is 0.28 into 10 raised to minus 3 divided by n. N how much? 4 into capital D 1.4. Okay na? So if we solve this, you will get the answer like 0.336 into 10 raised to minus 5 divided by 5.6, and if you solve this, you will get something 0.06 into 10 raised to minus 5. So if you shift points 1, 2, 3, 4 points, you will get 600 into 10 raised to minus 9 meter, that is 600 nanometer. Okay, so next, this is first case. Second case, what they given, and also find the fifth dark fringe. This is dark fringe from the central bright fringe. So now distance of fifth dark fringe, that is xn is equal to n minus 1 by 2 into lambda capital D by small d. Okay, so now what is n here? Fifth, right? N is equal to 5. 1 by 2. What is lambda? 600. See, we got this 600 into 10 raised to minus 9 into what is capital D? 1.4 divided by what is small d here? 0.28 into 10 raised to minus 3. So if you do this, this is 4.5 into 600 into 10 raised to minus 9 into 1.4 divided by something 0.28 into 10 raised to minus 3. If you do this, you will get 13780 into 10 raised to minus 6 meter. So it is equal to 13.7 into 10 raised to minus 3 meter. Okay, so this is how we have to calculate. This is x5. Okay, note down the readings. Please do your calculations. I might be wrong. Okay, yes. Next question will be like this. Light of wavelength 6000 angstrom is used to obtain interference fringes of width 6 mm in a Young's double slit experiment. Calculate the wavelength of light required to obtain fringes of width 4 mm when the distance between the screen and slit is reduced to half of its initial value. Okay, so now we are going to divide like cases, case 1 and case 2. So what they given? First case 1. Case 1, what they given? Beta 1 they given. How much? Of course, lambda they given. Light wavelength lambda is equal to how much? First write down 6000 angstrom is equal to 6000 into 10 raised to minus 10 meter. Okay na? Next, interference fringes of width. Fringe width is equal to how much? 6 mm. 6 mm. 6 into 10 raised to minus 3 meter. Then, so here we don't know d1 is equal to, d is equal to d1. Okay. Now, case 2. Case 2. Calculate the wavelength of light required obtain fringes of width 4 mm. Beta 2 they given. Fringe width 4 mm is equal to 4 into 10 raised to minus 3 m. Next, lambda 2 we have to calculate. Here, most important, distance between the screen and slits is reduced to half of its original value. If the original value is d2, means it is going to decrease by d by 2. Okay na? Now calculate here. So here d1 is equal to d. So whatever small d is same for both. Small d is equal to d, small d is equal to d here. Okay. So first we know that formula beta 1 is equal to lambda d by lambda 1 d by small d. Okay na? So now what they given, beta 1 6 into 10 raised to minus 3 is equal to lambda 1 6000 into 10 raised to minus 3, d becomes d and small d becomes small d. So we have to call it as equation number 1. For this, again formula beta 2 is equal to lambda 2 d by, that is d2 by d. So beta 2 how much? 4 into 10 raised to minus 3 is equal to lambda 2 how much? We don't know. That is lambda 2 only. Then d2 how much? d2 is equal to d by 2. Then small d. Call it equation number 2. So what we have to do here, divide equation 1 and 2. You have to divide these two equations. So then equation 1 is equal to 6 into 10 raised to minus 3 divided by 4 into 10 raised to minus 3 is equal to equation 1 how much? 6000 into 10 raised to minus 3 into d divided by small d all divided by, what is equation 2 here? Lambda 2 into d by 2 divided by all divided by small d. See here, this d get cancelled, this capital D get cancelled. We only left out with, see here 2 2s are 4, 2 3s are 6. Okay na? Now we only left out with 3 by 2 is equal to, so minus 3 get cancelled. Now 6000 into 10 raised to minus 10. Here there is a 10 minus to 10 raised to minus 10 because angstrom to 10 raised to minus 10 angstrom bit. Okay. Now into divided by lambda 2. See, this is 1 by 2. Denominator of the denominator is becomes a numerator, that is 2. Then what is lambda 2 here? Lambda 2 is equal to, take this 2 into this side, 6000 into 10 raised to minus 2 into 2 into 2 divided by 3. Okay. So if you do this, you will get the answer like 80,000 angstrom. This is the value of what? Lambda 2 value. Okay. See, first what we have to divide this question into two parts, case 1 and case 2, and we have to solve separately. Then we will get the equation 1 and 2, and we have to do equation 1 by equation 2. You will get the lambda 2. Okay. Yes. Copy this and do your calculations. Yes, dear students, this is all about today's class. So ಯಾವ ತರ ಎಲ್ಲ questions ಕೇಳಬಹುದು ಅಂತೆಲ್ಲ we solved already. So ಇನ್ನೂ ಏನೋ ಡೌಟ್ ಇದ್ರೆ please do comment section ಅಲ್ಲಿ comment ಮಾಡಿ. If you like this video, please share your friends and click on the like button. Okay, we'll see you in the next class. Thank you.